All right, let's learn about force versus time graphs, and let's illustrate how an impulse can change an object's momentum using these Fvt graphs. Here's one right here, and let's establish that an impulse is a force exerted during an interval of time. So it often happens during a collision. Here's our time on the x-axis, and here's our force. And there's a force being exerted on that object. We use this force versus time graph to analyze the impulse on an object. Notice how it has this triangle shape, and the max force is at the peak. Often in a collision, we collide, the objects first start touching, they feel a little bit of force, more force, more force, and there's like a peak, and then as they stop pushing on each other so much, we diminish our force back to zero when they stop pushing on each other. So here's a force versus time graph. Awesome. Let's watch that one more time. As soon as the soccer player's foot touches that football, we start to get a force. And then we have a max force and we diminish back to zero. We see that triangle shape again. Now, an impulse changes an object's momentum. That soccer ball experienced a change in its momentum. Now, here's the cool thing. The area of the force versus time graph that shows the change in momentum on an object. So if I look at this graph over here, the area of this triangle, that shows the change in momentum on the object. And in this case, it's 12. Now, how did I get that? Well, the area of a triangle is 1/2 times the base times the height. And I just looked at the base of this triangle was 3 seconds. The height of the triangle is 8 seconds. And then I used the formula for an area of a triangle, 1/2 times the base times the height. And you end up with 12 as the area. And remember, because this equals the change in momentum, our units are kilograms meters per second. So if this were the soccer ball, that soccer ball would just gain 12 kilograms meters per second of momentum. Here's another soccer ball video. Yowza. Okay. Well, just note that objects in a collision exert impulses of equal magnitude on each other. They push on each other during the same time interval. They have the same time interval, and they exert the same amount of force. They're force pairs, right? That's Newton's third law. And here's an example. So before a collision, let's say we have a blue cart and it is moving to the left at -5 meters per second. And let's say that cart is 2 kilograms. Then we can analyze with the force versus time graph during the collision. And during the collision, we can calculate the area, 1/2 base times the height, and we can see how much its momentum changed. It looks like it got pushed to the right because we're in the positive range of this force versus time graph. So this cart was moving to the left, and then it got hit by something, and it pushed it to the right. And let me get rid of my little box here. And that diminished its speed by quite a bit. Look, now we're at -3 meters per second. We lost some speed. We didn't lose any mass. The blue cart's still 2 kilograms. But this makes sense to me because we started with -10 kilograms meters per second. The impulse changed its momentum by 4 kilograms meters per second, +4, and we end up with -6 kilograms meters per second. This force slowed down that car quite a bit, pushed it in the other direction. All right, now here's one for y'all to try. So for this one,